Good morning, everyone. It's glad to have you all join us here today. This is Tony Sanders, State Superintendent, back for another Fireside Chat. Just as a reminder, I do a Fireside Chat usually twice a year, and it's always to bring to you, my fellow educators, superintendents, principals, and teachers, really people of significance that I've met or who've been introduced to me through other means. We've had people such as Simon Sinek was my very first Fireside Chat. Goldie Hawn came for a Fireside Chat. So you'd never know which celebrity is going to come next to our Fireside Chat. And today is one of my favorite ones. Jason Latimer is joining us. He is a world-renowned magician, the founder of Impossible Science, a world-class magician, in fact, the world champion of magic, has worked alongside names that we all know and love, Penn and Teller, Siegfried and Roy. Jason, I'm not going to go through all your awards because we would be here all day long. But it is such an honor to have you join me today for a Fireside Chat. I really do appreciate it. I will note they won't let me actually have a real fire. It's against the law, apparently, in Illinois for me to actually have a fire in my office. So we don't have a fire. But thanks again for joining me here today. It's great to have you.
Thanks for having me. It's an honor to be a part of the show, and I'm super flattered that you know so much about the magic background, my magic background. You know, most of my time I'm focused mainly on education these days, but still bringing the magic side to it. So I'm happy that you know.
For those that don't know Jason, like Jason, I told you, I've been watching every video I could get my hands on. From your early days as a true magician to your education videos, your TED Talk, your appearance on The View. So if you don't know Jason Latimer, all you have to do is plug it into Google and you're going to be inundated with so many videos you won't know what to do with. But it's so great to have you with us here today. Tell me a little bit about your journey. You know, starting off in magic and the curiosity around magic, which I still have. Now, how did you jump into education from that, and what inspired you to do all of this?
Well, I started off as a kid that just loved magic. And as I grew up in the magic community, I started to learn that if we knew a little bit more than geometry, we could probably do cooler things. So rather than jump into a box to vanish, the idea was, what else do we not know? So I started studying applied science, went to UCSB, focused on mathematics, game theory, and physics. And I just kind of built my magic tricks based on applied science. And then I ended up winning the world championships of magic. And I was like, this is a good idea. I'm going to keep doing this. Like instead of sleight of hand, I was like, could I apply science towards a magic trick? And I built the stage show. I had a blast. I toured the world. But it wasn't until I gave that TED Talk that you mentioned where I changed my own life. I ended up saying, you know, maybe I don't need all this information to try to trick or fool somebody, but could I inspire somebody to ask a question? The crux of the TED Talk was how the right question changes everything, and that it's wonder that changes the world. And so the idea behind it is, could I use the skill set of everything I've developed over my lifetime to design science experiments that look like magic tricks? And so the idea was, originally I got into magic because I was so excited about what is possible as a kid that as I got older, I started asking a deeper understanding of, well, how do we know what is possible? And it comes down to that right question changes everything. And so, like, how do we inspire curiosity and wonder in the next generation? And that's what I've been up to for like the last 10 years. It's been developing a museum platform of stage shows and exhibits, the online series, which is countless videos of basically whatever I've created in the Science Center and turned into a lesson plan for teachers to use, especially during distance learning during COVID. And now we have our summer camps. We now have touring science centers. It's all based around one thing: get kids excited about asking questions about what they could do with the knowledge they have. And if you don't know that it's not possible, why couldn't it be possible? So ask more questions, because we don't know what we don't know. So in short, I'm using my powers for good now.
Well, hopefully not always. Hopefully you do the occasional magic trick. In fact, hopefully today we'll do at least one of them. But
all the time. Actually, that's a really good point that you pointed out. By the way, it's very important to me that kids understand I have no superpowers, none whatsoever. And I have no problem admitting it. I just am a person who asked a lot of questions in different fields. And if it looks like magic to someone, then you need to ask more questions in that field. And so it's very empowering for kids to say, well, it looks like he bends light with his hands, but now you might be interested in physics and learning what you can do with light in your hands. And so, you could ask the same questions and you could do it better than I did it. Or you ask different questions and it's better than I could have ever done.
Well, I love, like, in your YouTube where you talk about, the assumption that we can't walk on water, when in reality, right, if you ask the right question and you apply science, there actually is a way. You just have to figure out how to make that happen, right? I mean,
so
that's what you're doing here.
Yeah, the idea behind it, like, let's take a concept that's easy for people to process, which is, like, let's say levitation. Now, a lot of people would say you can't float, but the reality is levitation is just a balance of forces, one pushing up versus gravity pushing down. All right. So the idea behind it is, if you built a rocket pack and flew around the room, in my book, I count that as levitation. But there's also levitation out there that doesn't involve a rocket pack. And I have one. I want to show you this.
Yeah, love to see it.
We're in the Impossible Science Lab. This is where we film a lot of the new episodes. And I wanted to show you this. This is my levitation wand. Now, for scientists at home, this is a handheld Van de Graaff, battery powered. Now, I show teachers how to make this stuff out of PVC pipe and wool, and 99% of the stuff you see with Impossible Science you can build at home, and you'll never look at a 2-liter bottle the same way ever again. But for kids that don't want to learn how to charge things up, this is my levitation wand and how we can get something to float. So this is levitation. Now, for those of you at home, if you can see it, there's this object that's floating in the air. I have a whole bunch of different shapes I do, but really what's happening is this wand has created a static charge. It's now touched that item. This item looks inflated because it's got the same charge, and because it's got the same charge, it's repelling from itself. Or it's sticking to me. Hold on a second. I'm limited to the chair that I'm in. There we go. And so now this has got the same charge as that, and so they're repelling. That's levitation. And all a kid needs to do is see that to know that it's possible. Otherwise, you would have just said it can't happen. And by the way, that's not a trick. There's no secret strings or anything. This is everything with Impossible Science looks impossible, but it's been brought to life through science.
Right.
And if you understand it, it looks like magic. So.
Well, and it instills a sense of wonder, doesn't it? I mean, so talk to me about the importance of wonder in this work.
Oh yeah. So in that TED talk I mentioned earlier, it was about how the right question changes everything, how wonder changes the world. But it's, I talk about this for hours, but in short, the easiest way I explained it to kids is that there's never been a rule book of what can and can't happen. And if there is a rule book, don't forget we wrote that rule book. We wrote what we think can and can't happen. Not because we know, but because given what we've learned so far, this is what we think the rules are. Okay? And so that's what science really is. Science isn't about what can and can't happen. Science is about what is likely versus less likely given what we've learned so far. But that doesn't mean it's ultimately right. It just means what we've seen so far, these are the rules. And it's really important kids realize that education is just catching up with what we've learned so far, but it doesn't mean we know what's left. And so that's why I say wonder changes the world, because that's how you find a new cure. That's how you build a new technology. That's how you revolutionize the world, is you ask a question that no one's ever asked before. And education is just learning the questions that have already been asked before. That's it. We're playing a game without a rule book, and as a child, you've just come up to the table, and we're going to show you all the rules we've learned so far in this game. And maybe you can stand on our shoulders, see farther than we did, and ask the question we hadn't thought of before. And so once you explain those rules to a kid, you see them light up in the science center. Like, in one of our museums, you'll see something on levitation, and even though there might be 7 different stations on how to make something float, static electricity, air pressure, magnets, there also is quantum locking. There's a whole bunch of different stations that constantly reinforce there's other ways to do this. And you might have other tables you'll discover in the future, your own questions. And so that's why wonder is so important. It's the only thing that changes the world.
Well, the thing that continues to make me wonder, I've started playing around a little bit with artificial intelligence. I think our students are, obviously, they're way ahead of us. And it makes you feel like it's magic, right? I mean, you plug in a question and it gives you instant response, and it's just like you're receiving feedback from a human, and even for an adult to make it feel like that's magic. I can only wonder what a child thinks about when it comes to artificial intelligence. And I love to hear you talk more about, the internet and how everything that's on there is stuff that we've curated. Like it's making the assumptions that think the world is static and that it's only the knowledge base that we have up until this day. So talk to me more about, especially now in AI coming out. I'd love to get your updated take on the internet and students.
The easiest way I think we can deconstruct the AI situation, first of all, I totally agree. AI is an extremely magical experience, especially for us that had never had it before. But I think it's really important to point out, we've reached a point, and this is also from that TED Talk, we've reached a point where the next generation of kids are going to forget that we gave the internet its answers. It's the internet itself is magical. When you grow up with it at your hands, they can no longer see the walls of the library anymore, so they can't understand limited information. And the best way to explain that, it would be, had the internet been around when we collectively thought the earth was flat, you'd never be able to search the internet for the true shape of earth via any search engine, because everyone's uploading the wrong answer, and then we ranked it by likes, clicks, shares, and views, and the most popular one went first. And there's a real problem with that philosophy of the most popular one goes first. See, in this race to get information with the age of information, by ranking things by likes, clicks, shares, and views, when does a revolutionary idea start off popular? It doesn't. By definition, revolutionary ideas only have one person that knows about it. And so that falls to the bottom of the search result. But the person searching the question doesn't know this new answer exists. So they grab from an already popular idea. Even if it's wrong or out of date, they grab an already popular idea. Now, if you're lucky and you have critical thinking and the skill sets to be skeptic of anything you see online, skeptical, that you may notice that this idea might be wrong or out of date, okay? But there's a problem with that. You've already clicked it. You've already made it more popular to the next user.
Right.
And so with every iteration, the wrong answers are climbing on the internet too. And so we have to be very careful about answers that have a huge head start that might be wrong. All right. And because we're now hoping that the next Einstein not only is a genius, but they have a search engine optimization plan for their idea on top of being a genius. And that's a very scary situation, because AI, as of right now, it's not really wondering. It's not really doubting its own answers. It's giving us the most popular answers that we've given it already. So it's not going to doubt what it's reading as much as it's going to give us the most popular answer given the answers we've had so far. Right. And that's why wonder is so important. And even though AI is truly magical, it definitely knows more than I'd ever know. But we do have to remember that that answer came from us. And if had we been back when we thought the earth was flat, the AI would respond with the earth is flat, because it's our answers that we uploaded to that it's great giving back to us by popularity and the most common response. So it's not the end all, but it's extremely magical because it talks to us like we do, and it knows way more than any of us. Now, that doesn't mean in the future this is always going to be the case. They may figure out how to get it to wonder and doubt and question. But as of right now, I think it's really important that kids realize the structure of the internet led to the structure of AI, which led to why it's so important for them to understand how to think critically in the age of information.
Yeah, we're doing a lot of work right now, working on guidance to school districts on artificial intelligence, and just honestly, just doing the research required to even generate guidance makes you realize the progression that we went through. That really, AI has been around for quite some time. It was actually the predictive. It was originally for the large language model. It was Google and other search platforms trying to figure out what you meant when you wrote something, right? Because we all type real fast on our phones, and it's trying to make some assumptions about what it is that you're trying to ask, and that's really the genesis for what Google's AI ended up becoming.
I use AI all the time, literally all the time. So I'm not anti-AI at all. I absolutely use it, but I do think we should be very careful about how the next generation uses it, not because of, I'm more worried about AI and the internet undermining wonder than I am saying that, it's great to have answers at your fingertips if you're willing to ask questions.
Yeah.
But if you're not willing to ask questions and you're not excited about what's over the horizon, then you're blindly going to follow this crystal ball that has a flaw in it. Yeah. That's the scary part for me, is it's very important that you make it to your adulthood and still be just as curious as you are when you were born.
That was the next thing I wanted to talk about, actually, was curiosity. Because and I'm going to pick on you to tell your story about from childhood and what really inspired you to even start thinking like a magician and then now like a scientist. But I want to, if you could tell your story, but then also share, how do we ensure our kids continue to be curious and grow into becoming curious adults that are always asking questions like you do?
Well, I was lucky enough to be, I joke around, raised by a pack of wild magicians. I was 9 years old when I saw my first magic show. I was on a cruise ship with my family. I saw a magic show. His name's Dan Birch, who's now a friend of mine. But back then, I was just a kid in the audience. And he did this levitation on stage of a woman. And I remember looking at my family going, "You lied." Like, I'm jumping out of trees with cardboard wings, and you lied. Like, this is totally possible. And it was like ultimately this feeling of, what do I not know? And that led to a lot of questions about how things work. The funniest part about it is that cruise ship was at sea, and after the show, the next day, I realized we hadn't been at port yet. So that magician must be somewhere on this ship. And so that poor soul, Dan, he was hunted down by a 9-year-old who ran through the entire cruise until I found him. And he actually showed me a card trick called Out of This World, which has led to my magic career, which fast forward, we became friends. It's just a really funny situation where I literally hunted them down. But I became a member of the junior program at the Magic Castle, which is for young people under 21. Magic Castle is a private club here in Hollywood. And through that, I met a bunch of magicians that used to have this conversation called effect versus method. So effect versus method. The effect would be levitation. An object floats around in the room. But the method could be magnets. It could be pixie dust. It could be wires of black rod. There's a bunch of reasons why it could be a solution that either looks like levitation or like static electricity. It actually is flying. But the method was the technique of how it's floating, and the effect is levitation. Effect versus method. Millions of ways to get the effect. Okay. So when I realized that we're limited mainly by geometry, I studied science to get more methods under my belt. Does that make sense?
Right. Yeah, absolutely.
So that eventually somewhere along the lines it clicked that we can do the same for science. Like I realized we can get a kid to stay curious by saying this section of the science center will be levitation, and we're going to show different methods at every single table. So it's still effect versus method conversation, but we're just trying to give kids a giant Rolodex of how many different things you could do to get something to flow.
Right.
But when it comes down to curiosity in a child, there's a professional development Impossible Science does that we're bringing out to Illinois soon, which is called the 1-2-5 method. So this takes a little bit of magic theory, but I'll explain it. A magic trick works because you don't know all the steps. Somewhere along the lines, you realize as an audience member, you found yourself staring at a situation where you're like, how is that possible? Why does this work? I don't understand the situation that I'm looking at. And that's because somewhere along the lines, you took a leap in information. The magician gave you all the steps and then didn't tell you about steps. And then you found yourself at the ending, okay?
Right.
After a lot of fuzzy logic and scratching my head and banging my head against the wall, I came up with the theory that you'd have to skip at least 2 steps to make the greatest impact with the audience. Basically, the idea behind it is some of the audience might follow skipping 1 step, but the second step would probably get more than just the first step. Does that make sense? Let me explain. Step 1 will be a setup. We're going to make an object float around the room, and with a thumbprint. And step 2 will be parameters, everything you can't.
Magic, right? Yeah.
That magic thing can happen anytime. Step 1 would be a setup, which is like, what are we going to do? We're going to make an object float around the room. Step 2 is what it won't be. It won't be magnets. Step 5, we're going to make an object float. 1, 2, 5. That's our method. Now kids will ask us questions about 3 and 4 because they took a leap in information. They were given steps out of order so that they have to ask a question. We're taking the structure of a magic trick and we're going to lay it over every science lesson we can come up with, which is exactly how Impossible Science was started. How do we inspire kids to ask questions? And that's to take the information we have to teach, like next generation science standards, and can I convert them into the format of a magic trick? And I said you have to skip a couple steps. You have to give them the 1, 2, 5, which is this idea of I know the answer, so I need to make sure that they can't follow the progression of thought. Because if I say we're going to use static electricity to make something float, it's interesting, but it could easily become I do, you do. I'm going to do this, then you do this, and it becomes very boring. If you do the 1, 2, 5 method, you can actually get a kid to ask a question and say, why does that work? How is that possible? And now we can go back and talk about steps 3 and 4 that we skipped on purpose the first time.
Right.
I don't know if that was the best way of explaining it, but the idea was I took the format of a magic trick and said somewhere along the lines, an audience member skips information. So
right.
What can we boil that down to so that it's a format that teachers could use to inspire curiosity in the classroom? And so after 10 years of working with the Science Center, we came up with this concept of the 1, 2, 5 and how to apply that to any lesson plan, how to apply that to any science experiment, how to identify the steps you should skip. And then we didn't stop there. We actually went a little bit further and said, what are the 3 attributes that make a bad magician? And how does that make a bad educator? And so the idea,
yeah, I want to hear about that.
Yeah. So if you don't know your own script, if you don't know what you're going to say, you're probably going to be a bad magician, right? If you don't know your own effect, like what could go wrong with your magic trick, you'll probably be a bad magician. And you can make and if you don't care about what's happening on stage, neither will your audience, and you'll have a bad magician. And if you think about that, if you don't know what you're going to say, you don't know your experiment, and you don't care about what you're doing, you're probably going to have a bad show in the classroom. And it's really important that, just like a magician, practice makes perfect. But take those 3 attributes of making a bad magician and apply it towards education, and keep those in mind. Then look at the 1, 2, 5. How do I deliver information to get the audience to land on an ending where they don't understand how they got there, and then work backwards to teach them. I've started to notice in the professional development, we're seeing teachers come in with lesson plans. They say, oh my gosh, this is something that's always worked. I've just never noticed it was a different format than everything else we were doing. Some science teachers will say, oh, I have my favorite lesson plan is this. And we look at it and it happens to accidentally fall on the 1, 2, 5. And so we started really developing that concept into, we know it works in the science center. How do we get it to work in the classroom? And that's what our professional development's about. And by the way, everything we've created from the Science Center is now breaching the walls of the Science Center. That's what's going on here in California on a massive scale, and soon to Illinois. And
yeah,
so,
let's talk about that actually. Let's jump to that, and then I'm going to come back to the mental shortcuts that we take. But while we're on it, I just want to say, Jill, I have to give a shout out, Jill Reedy, the regional superintendent over in Macon, Piatt County, introduced us at a reception. You had just presented all the regional superintendents across the state, and every one of them was talking about the water trick. They were, and so, and when you walked in the room, of course you had instant celebrity. Well, you are a celebrity, but everybody was clamoring to come over for you to do another trick or some, right? So talk to me about, you're coming to Illinois. I know you're going to be multiple places. Share out what you can about where you're going to be, and if people want to join in, like, how do they get? What do we do to get you?
What's about to happen is the most exciting thing I've ever seen with Impossible Science, and I've seen a lot with Impossible Science. So in short, I've been developing experiments for the last 10 years on invisibility, levitation, mind reading, animation. You name the impossibility, we brought it to life through science. It wasn't until 3 years ago I got a phone call about different departments of education, different school districts. People were calling me asking about, we love Impossible Science, we just can't get to the Science Center in San Diego, the Fleet Science Center, where I'm the curator of that museum. And it occurred to me, there's millions and millions of kids that will never be able to have access to a quality STEAM education. And somebody once told me, too bad millions of kids won't make it. And the first question that went through my mind was, why couldn't I move the Science Center? And so I called up all my old touring buddies from magic designers and equipment builders and case builders, and I brought them down to the Science Center, and I said, I need this room to fit in those trucks. And we did it. Now, fast forward 3 years later, we have Impossible Science camps and festivals. More importantly, the festival is a traveling science center, and it converts a gymnasium or auditorium into a temporary science center. To give you a perspective, it converts 5,000 square feet in 67 minutes. That's the record so far. So think high school gymnasium or middle school gymnasium. It moves the field trip to the campus so the kids have a mind-blowing, extraordinary experience with STEAM, turning things invisible like themselves, levitating objects like static electricity, everything you would ever see, reading each other's mind through mathematics, transforming shapes. Like this is my green thingamajig. It was actually created by Kokichi Sugihara out of Japan. This is the 4 circles, and if you rotate it around, you get 4 suits. Now this is a mathematical principle, 3 equations, 3 unknowns, applied. 3 equations, 3 unknowns. Perfect.
Got it.
All right. Now the easiest way to explain this is actually, as funny as it sounds, you have to talk about stars, but I can get a little bit into the science before I get back into it. Well, I'll just explain this trick really quick. If you had 4 stars in the sky and you point them out and they make a square, it's very possible those stars don't make a square from any other angle. And those stars could be closer or farther away, but as long as they're in those 4 points, it would look like a square from our point of view. Right. So the idea behind it is there's an infinite amount of ways you can make a square, but then there's also an infinite amount of ways you can make a triangle. And there's an infinite amount of ways you can make a circle, as long as those points are forward or backwards. And if there's an infinite amount of ways to make a triangle, and there's an infinite amount of ways to make a square, there will be an equation that a square equals a triangle from 2 different points of view. And that's exactly what this is. It's just 3 equations, 3 unknowns, equaling another equation of 3 equations, 3 unknowns. And it does take some geometry to figure it out, but it's important that the kids realize that these are not superpowers. These are just science in action, or STEAM in action. And like this is my invisible TV. I don't think you've seen my invisible TV yet.
No, I haven't seen this yet.
this is my invisible TV. So if our experiments that we do with Impossible Science Festival, which is coming to Illinois, turns impossible situations possible. So this is an invisible TV. Now, this film wouldn't just be in my hand. These are actually, they'll be embedded in a bunch of goofy looking sunglasses. And when kids put it on, they'll see this white, they'll have this white screen, but when they put on the goofy glasses, they'll realize it's a live camera and they look goofy to themselves. And so if you were on, if you're in middle school, this gives us a chance to talk about wavelengths, polarizing filters. If you're in elementary, we use the same experiment to talk about red, green, and blue make white. Equal amounts of red, green, and blue make white, which is why you're seeing white right now on the screen. This is a liquid crystal display, and the crystal is liquid crystal is actually rotating the red, green, and blue wavelengths. When I put up the filter, it blocks out different amounts of red, green, and blue. Different amounts of red, green, and blue make color, and so you have color on one side versus the other. But it's important that kids actually know that when they were doing the experiment, they realized there's no trickery involved. This is, I just don't understand this. And so this extraordinary STEAM experience is coming to Illinois. We're sending an entire team out there. We've got West Cook, West 40, McHenry County, Bloomington, Jill Reedy's, McCon, am I pronouncing wrong? Macon, sorry about that. Macon, Piat, and then Kankakee. We're going to be out there. And if you want more, you could probably contact us at impossiblescience.com. Scroll to the bottom, send us a message. Somebody will contact you. We're going to come out there this April, and we're running multiple days in each location. We're going to see thousands and thousands and thousands of kids. The museum is, our traveling science center is designed to see about 1,500 kids per day without a line. And so it's basically moving a field trip or an award-winning STEAM center to a campus, especially for areas that don't love the science center. It's designed to go different locations every day, but to be honest, I think we're expecting such a large volume of people that we're going to hold it in one location for 3 days and then bring everybody there, and then move it somewhere else for 3 days and bring it there. So, but it's very exciting because right now I have quite a few of them. I have 4 units on any given time in California, traveling around here. We've expanded to camps where I brought in, I called them a lot of favors from magicians I know around the country. And I said, hey, I love your magic with robots. His name's Mario, the Maker Magician. Trig Watson has holograms that come to life. Arthur Benjamin is the professor of mathematics at Harvey University. These are all magicians that I've called dear friends, and I've worked with them on their shows. And I have them come to our camps, and they kick off a camp with a magic show that blows everyone's mind. And then we spend a week learning curriculum of how would you actually do that in real life, not a different method to their effect. All right. So kids, Trig Watson made a hologram come off the screen and he was able to interact with the hologram. How would you make a drawing move? And so we use density to make a drawing come off of a surface and make it move on its own. And so Impossible Science Camp is literally about how would you make the impossible possible through STEAM. And at the end of our camps, we usually bring a festival in town. And so now, not only did you have a mind-blowing camp, but now there's a museum on your campus for everything you couldn't build on your own. And yeah, we have quite a few of those here now. We had 27 camps last summer. And now Impossible Science was just awarded LAUSD. So we're in charge of the secondaries. Thank you. We just had camps last week. All middle school STEAM camps ran through Impossible Science and starting January 5th through the 9th. It was a weird vacation week, but we're going to start taking over the STEAM camps during the summer for the middle school, and it's very exciting because I got quite a few tricks up my sleeves.
I'm sure you do. I mean, listening to the friends that you rattle off is just mind blowing to me. I love, I love the Penn and Teller. Their TV show. I know you know them well. I know you did a show with Penn and Teller at one point.
Wizard Wars with them. Right now they're doing Fool Us, which is great because it's magicians against them, and it's just like they're so brilliant at what they do, and I love their style because they never lie to the audience, and if they do, they're going to tell you that they're lying to you. Like they'll actually say something like, "We're going to lie for the next 5 minutes," and then but I like it because they follow almost the same philosophy, which is, you know, there's got to be a method to this idea,
and they're very educational. So I mean, that's why I was going to ask you. You talked a little bit earlier about how teachers can incorporate the 1-2-5 method, but like great performers, teachers have a dramatic impact on students every day. So talk to me about the parallels between being on stage and in front of an audience to do a trick and being on stage in front of a classroom trying to instill wonder. You talked a little bit about it, but like,
back in the day when I was building and designing new tricks all the time for me to do, or illusions for me to do on stage, funniest part about it for me is some of these illusions took years for me to design or iterate, like the clear cups and balls that follow the game, but under cups that are clear glass. That has taken me decades to perfect, and I'm still iterating it occasionally. I have an illusion where I bend light. I'm on my 6th version of building that prop. No one's asking me to change it, but I decided I just want to change it. Shaping water, I've done that so many times when I roll water into an object and I hand it to somebody. Most of the time when I'm on stage and I perform it and the audience applauses, I'm just as excited as the audience because I built it and I'm actually pretty happy it worked. Because you know, there's not much of a warranty with the stuff I'm building, but as far as like perfecting as a performer, you know, nothing makes you better than just rehearsing over and over and over.
Right.
And that just comes from pure experience. That's why teachers that have been around a lot longer, you know, they become bulletproof. There's literally nothing they hadn't seen in interaction with kids. But we also get rooted in our old ways. Our illusion of knowledge says this is the best way to do this. This is the only way to do this. When it comes to structuring the 1-2-5 over a lesson plan, you just have to remember that in a magic trick, the magician has chosen not to tell you certain things at certain crucial moments. That's what the concept of the leap of knowledge, leap of information is. There is information that is held back on purpose, right? So when we go through a lesson plan and we take any lesson plan and we start identifying the 1-2-5, it takes experience to say, okay, what would make this very obvious to understand what's happening, and what would make, like if I said static electricity before I did the levitation, there wouldn't be any questions.
Right.
And the parallel to it would be like, if somebody said, do the trick where you take my watch off my wrist, you've already ruined it for everybody in the room because they already know what the ending is, and they already know what's going to happen, and there's nothing magical about it. So it does take experience to say, okay, what are all the steps, and what steps could I remove that would make this baffling? And that's what we need to do, is remind teachers that you have all the steps at your disposal. It's just, what can we take off the table first so that we can get a kid excited about what the answer is? And that's all it is. It's not teaching anything new. It's just trying to identify what would change it from being I do, you do, to a real mystery that makes everybody start talking to each other, including themselves and to the teacher. So,
and then like a good magician, you also, I assume, if a trick starts to go the wrong way, you have many tools in your tool belt that you built over the years that you can pull from, right? To get it, either get the trick back on track or to shift to something different, I would assume, right?
So perfect example. So let's say I show this right here. Remember, it was script, effect, showmanship. So let's say I hold up this plastic right now, and all of a sudden the color doesn't look right. Okay, I know this effect forward and backwards. I know everything that could possibly go wrong with this effect because of my experience of doing it, but also because I took the time to understand the effect. That's what I mean by you have to know your effect, what could go wrong. So that means that's what the practice comes in. Now, if you're actually curious about what's happening, it's because the filter that I'm using is rotated 90 degrees. And so if I just rotate it, I've got my color back. Okay, now that could be very magical to somebody who doesn't understand a polarizing filter, but it also could be very confusing for the person that's operating it if they didn't take the time to realize that 90 degrees will change the color. So it's really important that the time to understand your own science experiment, not read over the experiment and say, oh, I got the gist of this, but to actually try it out and see what could go wrong with it. Just like if the static electricity, let's say this clinged at first, right? If it's coming off, it's because it doesn't have enough of a charge. It takes the experience to work with it to realize what would make this work, what would make it fail. And that's just like a magic trick. What could possibly go wrong in my magic trick, and what will be my out if I do have a problem with it?
That's what it is, the out, right? That's
so I have this one trick where I give a Rubik's Cube to an audience member to prove the difference between impossible and unlikely. Now, this is from my Impossible Science live stage show, which is basically, I give you a mixed up Rubik's Cube and I say, I want you to solve it in a few moves, 3 moves or 5 moves. And it seems very impossible because you wouldn't know. You also don't know.
It would be impossible. I've never solved one. So I can tell you.
You don't even know if it could be solved in 5 moves, so it feels very impossible, right? So I put that one down and I bring out another Rubik's Cube that's perfectly solved, and I ask the audience to call it a number, and then whatever that number is, maybe 1 through 7 or something, we crank it that many times. Now, when I give you that Rubik's Cube, let's say the number was 7 that was called out, we crank it 7 times. Now, when I say solve this Rubik's Cube in 7 moves, it's not impossible, it's just unlikely. Does that make sense? Like, we now know it can be solved. Now there's a surprise ending at the end of that magic trick as far as a prediction of what happened was with the mixed cube. But the point is, things can go wrong with this effect, because I once asked an audience member to call it a number, and I used this beach ball to have people call it random numbers. And I said, throw the beach ball to somebody else. And all of a sudden, let me start from the beginning. I bring a child up on stage and I gave him the Rubik's Cube to try to solve. I throw a beach ball up in the audience and I have them call out numbers, and they're supposed to mix up the Rubik's Cube. I once said, throw it to another person, and I see the beach ball, and then out of the corner of my eye, I see the Rubik's Cube come flying out over the audience. The kid had chucked the Rubik's Cube into the audience. Luckily, everybody saw it coming, but the Rubik's Cube hit the ground, shattered into a bunch of pieces. And normally, had I not done that effect before, I would have said the show is now 2 minutes shorter. However, I knew that somebody could make a mistake, and I reached into my box and I pulled out another Rubik's Cube and handed it to the kid as if it was just a reset. And that's the difference between knowing the effect and doing the effect. Doing the effect means it could have ruined it. I may not have had everything covered. Knowing the effect of what could go wrong, dropping the Rubik's Cube, spilling the Rubik's Cube, break the Rubik's Cube, having a spare one sitting next to it became funny. And, Eagle Scout. Totally prepared. Totally prepared. And but yeah.
You really are an Eagle Scout? I didn't see that in your bio.
Yeah, very much an Eagle Scout. And
that's amazing. That's amazing. So where do you see Impossible Science going next? You said, obviously you're coming to Illinois. You've got at least 5 locations. You'll be here in April. But what do you see coming next?
Over the future of Impossible Science, it's very broad. I'm partnering with Orlando Science Center. I'm running like 24 shows over there. I'm putting another 24 shows in Buffalo Museum of Science in New York. That totals now 8 museums across the country that are using the Impossible Science format. Impossible Science camps are continuing to grow in California. I'd love the opportunity to do them anywhere else. If people want to do them, I'm down. More power to your regional offices of education are so exciting. I can't thank them enough. All I said was, if we can get 5 consecutive days together, I'll bring the Science Center over here and we'll just run them. We're now going to be out there for almost the entire month of April because everybody's added on. So this will be the first time Impossible Science as a festival has left California. So this is very exciting. It'll be the absolute first place to do that. I'm now building more experiments faster than I've ever done it before, because we found out that the kids, there's like a high 90% 90 percentile chance that they're going to come back to the following camp. So now I'm back working on more experiments. I am just super excited to make this type of thought process in education available to everyone, everywhere. Because if I really believe that the right question changes everything, I have to acknowledge that that question could come from anyone, even if they're in a remote town, in a rural community, and they don't have a science center. And I always, how do we know the next Einstein isn't living in a rural community?
Mm-hmm.
And the answer is we don't. And that right question that changes the world could come from any of us, anywhere. So we have to be able to make this concept accessible to everyone. And that's what the festival is doing. It's and I'm so thankful to be a part of it, and I'm so thankful for everybody in Illinois for bringing this out there, because it's just very exciting.
I love it. Jason, I love your energy. So I told the story at the beginning that we met at the reception after the regional superintendents all met with you, and you wowed them. And then the next morning, I got up in the hotel here in Springfield, went down to the lobby, and who do I run into? Jason Latimer. So we sat and had breakfast together. And one of the things I love about you is the energy that you gave at 9 o'clock at night at a reception was the exact same energy the next morning at 6 a.m. at breakfast. You seem to have an endless supply of energy, smiles, and passion for serving kids. And it just speaks to my heart, just so you know.
You know, I feed off of the energy off of everybody that gets excited about what we're doing. Only makes me want to work harder. Like, I remember coming down to the Science Center in San Diego. When I first got to the Science Center and said, when I first came up with the idea of trying to build a science program that inspires curiosity and wonder rather than shoveling answers, I called every science center in Southern California. I live in Los Angeles. And the only reason we started in San Diego is because that was the only museum that called me back. Most of them were like, why is this magician trying to do this idea? And what was supposed to be 8 weeks off of my normal tour schedule. Back then I was still touring amongst casinos, I was actually still on Wizard Wars with Penn and Teller. And I said I would do 8 weeks to see how it worked. And the show ran for a year and a half every weekend for 6 shows a weekend. And the only reason it stopped is because I needed to stop. I didn't even live in San Diego. I was commuting 2.5 hours just to prove a point every weekend. And since then, now it's been a decade. Impossible Science has grown dramatically. The Fleet Science Center is now working on a new wing to permanently house Impossible Science year round. And we're just seeing such an impact on such a scale with such an excitement behind it that it's hard not to stay constantly excited about this thing. And so as long as everybody stays motivated, I don't see myself stopping anytime soon. So
that's awesome. That's awesome.
Who knows what's going to happen in the next few years? I know we're coming to Illinois.
Yeah, I know you're coming to Illinois. So and I'm going to pick on you on that one as well. So every state that I talk to, we're all doing the same work. We all have a comprehensive literacy plan of some sort. We're all focused on science of reading. We're in Illinois, we're working on a math numeracy plan right now. Everybody's trying to change the way that we're asking our teachers to teach, instruct both math and reading. And I keep telling everybody science is going to be the next one. Like we have to do that next. And if we could go back and recreate it, we probably should have done them all at the same time, because everything is interrelated, right? I mean, you got to be able to read to do science, and math and science clearly you have to, they go hand in hand.
Absolutely.
But nobody's really talking at the national level across the states about science, and I'm wondering what your take is on that. Like, what can we do to really ensure that science is taught every day in every classroom across our country? Because I fear that it's not happening everywhere every day.
Yeah, I 100% agree. We don't seem super on top. Like, it feels like science has become a subject rather than a way of thinking. And we really need to point out two parts of it. When you hear the concept STEAM, there's a lot of people that are out here like, oh, let's have a STEAM course. And they think of it as a course or something, an elective. But the way I look at it is this is a framework of tools. These is, again, I get a lot of these conversations through a bunch of kids at the Science Center, and I point out how, it's funny as it sounds, I go, how many people have taken apart a refrigerator? And kids go, no, I'm not. Like
I have.
And I go, all right. So even though you've never done it before, could you take a guess of what tools you'd need? And they go, yeah, screwdriver, you might get a hammer, you might get a wrench, you might get scissors. But all in all, you could actually, if you did have a list, you could probably come up with a fairly close list of what you really do need to take apart a refrigerator. My point behind this is, even though we don't know what the job of the future is, we can take a pretty good close guess of the tools you're going to need to do those jobs. And that's what STEAM is.
Yeah.
You're going to be really hard pressed in the future to find a job that doesn't require science, technology, engineering, arts, or mathematics. And honestly, you can use any of those to help the other. Like you were talking about how they're intertwined. Like you really can't paint unless you have the chemicals of the paint and the mixture of the paint. You really can't build a robot unless you had the engineering of the servos. So like they're all intertwined, but the more tools and the more use of those tools in your toolbox will allow you to build more in the future. So I think it's a concept of nation. If we're lucky enough, we're going to be able to find a way to inspire kids to say, wait a second, I could be wondering about a question that could change the world. Right. And if we're lucky enough, they're going to realize we're going to need these tools to ask better questions. And that's my game plan, is to reach every child everywhere with the concept that they could be wondering about a question that could change the world. But don't forget, you're going to need those tools to do it. So hopefully there's just going to be overall excitement in the concept of STEAM through Impossible Science. But overall, I totally agree. There's really not much that, I mean, there was quite a bit of a reset that happened with COVID. The USA Science and Engineering Festival hasn't been back. That's the Nation Science Festival. A lot of things have moved online because live events became difficult to do. But that doesn't mean they're impossible. So like here in Los Angeles, I'm heavily involved with City of STEM, which is like 30,000 people in one day. It's the LA Science Festival. Started with Ben Dicko and myself and a bunch of other people. We needed a science festival. We needed a local science festival. And then I kind of took that and made smaller versions, which is the Impossible Science Festival. But I think it's just going to be a matter of getting more people aware of how important this conversation is, because as far as in the LA community, I feel very confident that this ongoing excitement now that's actually happening with education, mainly because I'm super close to it and I watch it. I have my finger on the pulse of it here in Los Angeles, but I feel very positive around here.
Good. Well, I hope you feel positive about Illinois too. Illinois is doing great.
I know it's coming in a tidal wave to Illinois, so that's what I'm excited. I think it's just a matter of time, and it's happening. We're moving the needle. So I'm not. I maybe got to figure out a way to get more state superintendents. We need a bunch more fireside chats.
I can help you. I can help you there. We'll talk. I can help you get into more states. So what about a book? Are you somewhere there's a book in you, right?
Yeah, well, I mean,
at some point.
I do write quite a bit. We are up to a couple hundred experiments now. So but right now, my next step for Impossible Science is really about what happens year 3, year 4, year 5 if people keep coming to our camp. With this such a high attendance coming back, it's very important that I move to grade bands as soon as possible. So 6th grade doesn't learn what 8th grade is learning. 7th grade does not learn what 2nd graders are learning. Can I make an experiment like this not only work for 3 different age ranges, but say this only shows up for 8th grade? Is that possible? That's the first thing I'm doing, is making it fully scalable, turnkey, make it as easy as possible for everybody to do what we're doing. That's the first thing I'm working on. Maybe one day I'll write a book. Maybe I'll build more science centers. But right now, I think this moving the science center to a school is doing so much. It's really changing the game. You don't have any more buses. It happens unless you're bringing them all to one location. But in short, if you were to do it at a campus, you don't have to worry about buses. You don't have to worry about the logistics of especially the permission slip of the one child that probably should go on the field trip, but didn't get the permission slip. So you don't leave the campus. And it doesn't disrupt the school day. By the way, for any educator that's paying attention, you don't have to ruin the school day to have an Impossible Science Festival. The kids only go to the science festival during the hour that they would normally do science.
Yeah.
And we can have their science teachers help us out in the festival. So it's literally just meet us in the gym or auditorium, multi-purpose room. It's really changing that game dramatically. And I'm just going to build a gazillion of those.
You're just so impressive. You're just amazing. You're amazing. Jason, we have 3 minutes left, so I want to give time, first of all, anything you want to close out on, but I also want to make sure people know where to find you online, where to follow you so that they can follow you if they would like to. So this is your chance.
Impossible Science on anything, Instagram, YouTube. YouTube has all of our experiments that were played also on PBS, NASA. Sony sponsored me during that time, so we have quite a library on YouTube. Instagram, Facebook. You can follow, if you're interested in the social media, you can follow on any of those. If you're interested in bringing Impossible Science Festival to your school or district, especially being Illinois, we're going to need to contact you. So go to impossiblescience.com, go to the bottom, fill that out. We'll have somebody contact you. Hopefully we can tack it on to a tour that's already out there. Getting everybody to work together is the most important thing so that we don't zigzag. So it's going to be a team out there for like a month and then they come back. And I think that's mainly right now. That's the real one. Or if you have a conference or education bit you want me to come out, we met because Joe Reedy accidentally mentioned that everybody was going to be at one location, and I jumped on the plane and just showed up. So I always like to know what's going on, and the first step is know I exist. The second step is for me to know you exist. So I always tell people, if you know of what I'm doing, please let me know that you're interested so we can contact you and we can all work together. So
perfect. Yeah. Well, Jason, I can't thank you enough. You inspire. You're amazing. I look forward to seeing you when you come to Illinois. And anytime Illinois can be of assistance, let us know.
I'll make sure I send you guys the dates and you can blast out to everybody. Please come see it fast. You have to see it to understand it. It's one of those things that once you see it, you can't unsee it. Yeah. So
I do a weekly message to everybody, so we'll make sure we include the dates in there so that people know where you'll be, when you'll be there. And again, a shout out to all of our regional superintendents for bringing you to Illinois. It's amazing work, and we'll look forward to seeing you here down the road. I thank you everybody for joining for today's Fireside Chat. We said an hour, so we stick to an hour. But Jason, we'll see you down the road soon.
Take care.
Take care, everybody.